Okay, this is going to be a little bit short, I hope. I always say stuff like that and it ends up it's not the case. But I don't think I really need to go through. What you, I suppose, need to do is read this section on formal charges and resonance structures and go through and read all that. But I think you kind of know how to do it already because we did formal charges. So let's just wing it. If you run into a question, ask. And basically you got to pay attention to all of the arrows that are involved. Okay, so on 2.23a, it says for each of the structures below, draw the resonance structure that's indicated by the curved arrows. Make sure to include the formal charges. So this is what you would have. Okay, first of all, if you have a resonance structure, you're supposed to put this big bracket around it. Okay, then you go to this and then back. Now really, you ought to have a curved arrow going from here to there to show that it goes back the other way. Let me see where we're at on this, see if they did that in the answers. I don't remember seeing any like that. 2.23, yeah, they don't show that. But if you wanted this to go back, you'd have a curved arrow to there. Maybe I'll do those in another color later or something. Okay, on number B, you've got kind of a different thing with an extra pair of electrons out here, and this is negative. So if this pair of electrons went there, you'd have a double bond, which means these have to jump. You can't have a hydrogen here, 1, 2, 3, 4, and then put another bond in. But you can if the electrons in one of these double bonds jumps out onto the end, and then you have a lone pair out here on your carbon. Okay, and this is just the reverse, so if you could double arrow these back the other way. Okay, next one. Well, that was B. Okay, they're showing that if you take a lone pair out here and you put them in there, make a double bond, you can't do that because this carbon already has 4 bonds on there. However, it'll work if if 2 of the electrons jump out of this double bond and go out here where you have an extra lone pair out here. Okay, now this is a resonance, so you got a bracket, and you're showing that it can go back and forth, and it could go the other way. You could have a curved arrow showing electrons going back in here to a double bond, but then you have to show this double bond electrons coming out and jumping over here, or jumping out of here onto there as a lone pair, sorry. And when you're done, by the way, I guess I kind of need to go back one and highlight. Here you have a formal charge that's positive now here, a formal charge that's negative now here. Going to the next one. You now have a formal charge up here that's negative and one down here that's positive. And if you started with no formal charge, and you ended up with a negative, you'd have to have a positive. If you ended up with a positive, you'd have to have a negative. We'll talk more about these rules on formal charges as we go. Okay, well, what about this one? If this is what we have, and you have an electron pair that jumps down here and becomes part of a double bond, you can't do that because carbon has 1, 2, 3, 4 bonds on it here. But you can do it if one of these bonds here, a lone pair jumps out of here and goes onto the nitrogen. Now when that happens, your nitrogen ends up with 2, 4, 5, 6 electrons. So there's a negative on there instead of the 5 that it requires. This carbon had a hydrogen on it, you got 2, 3, 4, and a hydrogen, it's 5 negative. Carbon would normally start with 4. If it goes in there, you're down to hydrogen bonded hydrogen, and that one, and that one, and another one, you're down to 4. So there's no charge here, but we've put a negative charge up here because I have now, well, I already did that one. Okay, E. Okay, it looks like a phenol. Okay, if I make this double bond jump into there, or this lone pair jump in there and make a double bond, I've got too many electron or bonds on this carbon, so I'd have to have electrons jump out of this double bond and form a double bond here. But then I have too many bonds on this carbon. I'd have to have one of the bonds come apart and the electrons jump, the lone pair jump out of there as such. Once that happened, my oxygen would have 2, 3, 4, 5 electrons that it owns. So it's going to end up being positive because remember, if you're losing track, oxygen's in the 6 column, nitrogen's in the 5, carbon's in the 4. Where'd it go? Okay, it's on this one. So that's positive, and then the oxygen or carbon down here. Remember, there's a hydrogen coming off there, so there's 5 electrons that it owns. There's that double, that lone pair, and one in each of the covalent bonds, or one in each of those single bonds. And there's a hydrogen in there on a single bond too. Don't forget about it. Okay, if we move this double bond, take 2 electrons out of it, put it up here as a lone pair, we can do that. That's not a problem. But this already has a positive charge, so you're going to have to put some more electrons in there. And do that by taking 2 electrons out of a double bond here and sticking them there. And then you have a shortage here, so you have 2 electrons move out of this double bond and make a double bond here. That leaves you positive down on this end. You got a carbon on this corner now that has 1, 2, and hydrogen, 3 bonds, and you're short by 1 electron. Now, if you do that, you're going to have a negative charge and a positive charge and a negative charge and a positive charge. Just because I could draw it, and there's not a rule against it, doesn't mean that it's going to spend half its time doing this and half its time doing this, or that it's going to be 50% this character and 50% this character. This oddball isn't going to stick around very long. If you resonate these and you look at the character of these two, it's going to be much more like this than it is like that. The difference is, as you look at it, you're not going to be able to tell, which bond has more double bond character, and which one has more negative character. Because if you look at what's going to happen, it can go around the other way. Once it gets to this, it could go this way, or it could have these 2 sides could be reversed. There's nothing preventing that from happening. Okay, on G, yeah, you could have a lone pair jump out of this double bond, but since this is already positively charged, you'd want a lone pair of electrons to go in here and make the double bond here, so that these 2 are opposites of one another. They're mirror images of one another. That's not an important thing, by the way, it just happens to be the case. Now, remember when you draw your resonance, put a bracket around it, put the double-headed arrow in there, and it's basically meaning to say that it looks like it's both of these, it's got some character of these at the same time, that there's a double bond character here and here. There's positive charge character here for sure, but there's negative charge character here and here. All right. And the last one. And in this section. So if electrons come out of here and form a lone pair, that's okay, as long as this double bond can have a pair of electrons move from here to here. And once you do that though, you're down by a bond on this carbon on the end, so it goes from 4 bonds, because there's a hydrogen and a hydrogen, it goes from 4 bonds down to 3, and you have a positive charge, and you've got an extra negative charge up here. Okay, let's go onward here. Or not? Let's see how much time we got. We'll go a little bit farther. 2.24, in each case, draw the curved arrows required in order to convert the first resonance structure into the second. Begin by drawing all lone pairs and then use the formal charges to guide you. So in this one, what you're doing is putting your lone pairs in and then decide where the curved arrow has to go. And so it has to go here to show that the lone pairs go up there. I suppose you could, going back, you could draw this drawing first and then this one, in which case if you had it reversed, you'd have to draw the curved arrow in. Don't forget your bracket. B. Okay, once you draw your lone pairs in the way you're supposed to, and figure where your formal charges go, then you can figure where the curved arrows go. You have to take a lone pair out of that bond and move your pair of electrons from here to there. And C. Okay. If you draw the drawing in the book there and you've got your formal charges, then you'd know, okay, I have extra electrons up here, put those in a double bond here, but then I can't have 5 bonds on carbon, so I have to take this double bond and extract a lone pair out of it and put up here. So I need my curved arrows here and here. Don't forget your curved arrows. This lesson's about curved arrows. Okay, then D. If you draw what they've got, we have your double bond, electrons moving over here and making a double bond here. That will satisfy this positive charge, because right now you got a hydrogen bonded in 1, 2, 3 bonds, which is 1 short for this carbon. Move that double bond, it'll have 1, 2, 3, 4. But over here, instead of having 1, 2, 3, 4, you'd be down to 3. So that's going to have a positive formal charge there. Okay. That was video Organic26BBlake.